Hi, welcome to the another class of Internet of Things. In this class, we will study about the MQTT protocol. We have been studying about the various constraint protocols which are required here for the constrained environment of your Internet of Things. Because if we have the Internet services here, so this is your core constrained network. That means it consists of the various uh, small devices which have lower throughput and lower power requirements. So although the existing web infrastructure here can support the IoT, but the protocols which are used here are quite heavy for these smaller devices. So that's why we are using these lighter versions of protocols. Now, as we have studied, CoAP protocol, which is a constraint application protocol, which is used in alignment with your HTTP. This protocol uses your UDP, which is a user datagram protocol. So today we will study the next protocol, which is your MQTT. So MQTT refers to message queuing telemetry transport protocol. So this is basically a lightweight message protocol, that is queuing protocol and telemetry protocol. So that means this protocol here is able to fetch the information, or we can say that they carry the information from the telemetry sources. That is mean it is capable here of forwarding the telemetry data. Now that telemetry data is here collected from the various sensor and actuator nodes here. So like from sensors, you can have temperature control related data which is forwarded to the various application. So the configuration for this protocol here is like, if you have the sensor devices, so these will be forwarding the data to the application. So that is here forwarded with the help of MQTT broker to the various apps here. So I have such kind of configuration here for this MQTT protocol transportation. Now this will be my MQTT broker here. So the various sensor nodes, these will be my different sensor nodes here, or my actor nodes, which will be communicating with these apps with the help of this MQTT broker. So we can say that this MQTT broker is the centralized unit of this protocol, because the application and these nodes are not directly communicating with each other, but rather the data is collected here and then it is forwarded to the app. Now for example, we have light sensors, so that data will be captured here by this broker, and if that data is used here for an building application protocol, so then the data will be here transferred with the help of these brokers, and then whatever the necessary actions are required after that, this application will be guiding these actor nodes to activate that particular blind. So every node is here communicating with the help of MQTT broker here. So That means if this protocol is here suitable for your small devices, that means these sensor devices, then it is serving here your WSN, which is your wireless sensor networks, and ultimately your IoT applications here. So what are the features of this protocol here? So first of all, it is in lightweight. That means it is suitable here for machine to machine or for device to device communication, lightweight queuing, messaging, and the telemetry transportation of the censored data. After that, asynchronous communication model. Now, the previous protocol which we have studied here for your IoT, the previous convergence protocol, that was your CoAP protocol. So that doesn't implemented your TCP, transmission control protocol, but this MQTT here is working with your TCP, and this protocol is used in conjunction with your IPv6 over low powered personal area network used in conjunction with this network. Now, this protocol here is designed to work for constrained bandwidth requirements. That means the network have low bandwidth. So, it has a lower overhead or lower header, which is your 2 bytes. So, it is supporting here your lower network bandwidth. And the most important feature that this protocol here is responsible for the decoupling of your publisher. That means one who creates the data and the subscriber, like your client, with the help of topics. So topics are basically your message queues which are exchanged here between these two entities. So like you have publisher here who is generating such messages here. Now this is going through your MQTT broker to the various number of subscribers here. Now after this we will see the detailed architecture of your MQTT protocol, that how it works, how it is able to transfer the information between these various nodes. Now let's consider that you have here the sensor, that means you have the application here. This is the application here. Now after that you will have MQTT clients. So these are basically your publishers or your subscribers. Now this will be my MQTT session here between the MQTT client and the MQTT broker or the server here. Now this server then here has a number of topics. So this MQTT, this is your complete MQTT server. This is your complete block, which is your MQTT broker or your server. Now here you have the client subscription. Now these, we know that this protocol works here with your TCP. So where do I have my TCP network? This is here connected to your TCP IP network like this. It exists here and then connected to your server section also. So this TCP IP is here. This TCP transmission control protocol network is here connecting this client and the client subscription here. That means the MQTT server or the broker. So the various crucial elements in this architecture of MQTT starts from the application. So it could be any kind of application, but the data has to be transferred here between these nodes. So we have then the MQTT client here, then the MQTT server, the session, the client subscription, and the various messages which are exchanged here. So these messages are basically like transferred here. My MQTT messages here. So first of all, I have the MQTT client or which consists of your subscribers and the publishers. So MQTT client basically wants to send messages to the server and to receive the messages from the MQTT server. So this is basically here in conjunction with the application. So this is regarded as a user which is sometime here responsible for the publishing the data and acting as a subscriber when it is retrieving the information from the server. So client is here accessing the services of this protocol, or client is the one who wants to access the server. So we have here subscriber and the publisher. Now after that I have my MQTT server which has topics and client subscription. Now server is here responsible for forwarding the messages which it receives. So it keeps the database of the various messages or all the information and then forwarding that messages from the clients and to the other clients here. Now I have these various blocks here. These are called as topics. So topics are basically your message queues which consist of different number of messages. So that means this client and the server are able to forward this information with the help of these topics here. So these are basically your message queues. For example, it will be consisting a different number of measurements or data from a temperature sensor device here. Now after that I have this client subscription. So the scenario is here you have the publisher, then you have the topic, and then you have the subscriber here which are exchanging the information. Now I have client subscription here. So client subscription basically refers that logically that when you are subscribed here, it logically attaches you to the next client. So this client subscription here allows you to logically connect to a client, or we can say that the topic on the basis of which you will be redirected that information. Now after that you have the MQTT session. So this MQTT session here is established between these two entities, the client and the service, which indicates that yes, these two entities are communicating with each other for this interval of time here. So session is just established here between the client and the server, and the various messages are exchanged here between these two entities in this particular session here. So this is the application, this is the client. Then you are using this complete infrastructure on your TCP network here. It is connecting here your clients and the server. Then we have the client subscription here, which means that it logically subscribes you to a topic. So topic is basically the message queues, and message is the smallest data unit which is exchanged between the application and the nodes here. So this is the infrastructure here for your MQTT protocol, that what are the various elements which are used here for transmitting the information in IoT constrained network here. Now this protocol is here specially designed according to the bandwidth limitations, so it has a smaller header format also. So what are the different kind of messages which are exchanged here for your MQTT? So the next thing which we have is MQTT message format. Now it has two types. First is your mandatory, and second one is the optional. Now mandatory one is your 2 bytes header, which will be always in your MQTT message. So this is your header field. Now in optional you have either variable length header and variable length message payload. So these are the two types of messages here. Now we will see that how these are arranged here in the MQTT message format. So here is my first 2 bytes field, which will have, this will be your header message. It will consist of these fields. First of all, it has the message type, then you have DUP, then QoS, and then retain. So this is your mandatory field. After that, remaining length, which basically indicates the number of bytes if there are any remaining. Now next we have the optional part here. So in this optional section you will have the optional variable header length, and then you will have variable message payload here. So in this mandatory section, the first one which we have is the message type. So this field basically indicates that what are the different types of messages which are being exchanged between the client and the server here. So the different kind of messages which we have here are like here, like connect, then disconnect, acknowledgement, then the message is published, that means transferred, published, then it's acknowledgement, then subscribe message, it's subscribe or subscription acknowledgement, or whether it's unsubscribe message. So these are the different kind of messages which are indicated here in the message type field, having such values. Like if it has one, so it means connected. Now after that, the next field is your DUP, which is your duplicate message flag. So this duplicate message flag field, DUP is for duplicate. Then we have a duplicate message flag. So this flag basically indicates that this message is, if a message is already received here, so if that message is again being transmitted, so the value of this field will be high, indicating that this message might have been received earlier. Now after duplicate flag, next is QoS, which is your quality of service. So quality of service here basically is used to tell the assurance of the delivery of the messages, the published messages, that with how much accuracy they are delivered there. So that indicates the quality of the service which is provided by this protocol, that yes, these published messages have been transferred there. Next is your retain field. So retain field basically ask the server to keep in hold the last message which has been transmitted, the last published message which has been forwarded. This field asks the server to keep that message retained here. So these are the mandatory fields. Then you have the remaining length here after these fields. So now we have the variable section, in which you can have the variable header length and the variable message payload. So these are the different messages, and this is the message format here for your MQTT protocol. So this was your message queuing telemetry transport protocol, which is used to gather, or we can simply say that which is used for the transportation of your telemetry data, which is collected from various sensors and actuator nodes. So this was another protocol which is used in your IoT systems here. So this is all here for today's session. We will study another protocol for your IoT in the upcoming session. Thank you so much.